So first I found the circumference of the whole circle, which equals 2 pi r, which equals pi d, which equals 24 pi. Then I got one sector, which gives us, it says 120 degrees, and we know that these lengths are 12 because the radius of the whole circle is 12. So then we can use the equation of the circumference of the sector to find our circumference. So we can do the part over whole, so it's the sector degree over the whole circle degree. So 120 over 360 equals the circumference of the sector over the whole circumference of this circle. So that equals 1 over 3, which equals circumference of the sector, which equals 24 pi, and then we get our circumference equals 8 pi. So we do the same thing for the 180 degree sector, and we get circumference equals 12 pi. And then moving on over here, we can use the circumference we got to do c equals 8 pi to find our radius. So we could do 2 pi r, which is the circumference, equals 8 pi to find our radius, which is 4. So it is the radius right here. And then we could use the volume equation, which is v equals 1 over 3 pi r squared times h. And that gives us v equals 1 over 3 pi 16h. And we know that for both sectors, h stays the same. So for the 180 degree sector, we know that the circumference equals 12 pi r, so we set circumference equal to the sector circumference, which gives us the radius of 6. So then v equals 1 over 3 pi 36h, and as we can see, the 180 degree sector has a greater volume. So for part B, when theta is greater, then the volume of the cone will be greater, so you have to find theta that's greater than 180 degrees. So to prove this, we're going to be using some variables. So first we're going to use the circumference of the last circle, which was 24 pi, and then we're going to use the circumference of the sector equation, which we've been doing. So theta over 360 times 24 pi, which equals the circumference of the sector. And then once we do our math, we can get that the circumference of the sector equals pi times theta over 15. And then we need to set that equal to circumference to find the radius. So the radius equals theta over 30. And then using the volume equation, we could plug the radius in. So we get volume equals pi theta over 30 squared h over 3. So this tells us that as theta increases, so does the volume. So on part C, we can use the equation we got from part B. And remember that we're going to be using theta over 30, and we're going to set that to x because we don't want our radius to be a fraction. So we could use a sector and do Pythag to find the height. So we know this is 12, this is x, this is the height. So once we do Pythag, we get that the height equals the square root of 12 squared minus x squared. We can plug that back in into our volume equation, which gives us pi x squared square root of 12 squared minus x squared over 3. So to find the maximum volume, we can use the equation we just found and then plug it into any graphing device to get the maximum volume, which is 696.5.